Thank you for joining me in the discussion of my master thesis titled Perceptual Distortions in Cartography, Maps for Trickery, done at the Technical University of Vienna. To begin, I would like to point out that humans do not process information in an entirely rational and logical way, and that we already know that we have some problems understanding information visualization. So my question for this research was, what are the effects that impact map reading, and what is the way to study these effects? To be able to answer this question, I set up the objective of identifying cognitive effects that are triggered during map reading that create unconscious, unintended impacts in the way we process information. To be able to fulfill this objective, I reviewed literature, I developed a user testing platform to test some effects, and then I analyze and reflect on those results. In my literature review, I was able to understand the context of these effects, and I found out that there are two types of them: cognitive biases and optical illusions. And I proposed a concept, perceptual distortions, to be able to group them on a new theoretical framework. I also found out about some singular effects that were tested already in the context of map reading. I chose some effects to test in the empirical phase, and I did my selection based on taxonomies that analyze biases in information visualization. I only considered the effects that were already proven to have a relevance in this field, and I also choose only the biases that don't have strong cultural components that are harder to control. For my research design, I created some maps in which I translated the biases into cartographic language. I created two versions of each map: a baseline standard design that was based on current map-making guidelines, and a bias-inducing version which tried to explicitly trigger the bias. The contestants were either served one or the other versions of the map, and then I tested their performance on map reading. At the end, I had 174 participants. The first bias that I want to talk about is the clustering illusion, which describes readers seeing inexistent patterns in random distributions of data. I created these dot density maps, and I increased the level of detail in the bias-inducing version. And my hypothesis was that users exposed to more of these local patterns in the bias-inducing version would mistakenly generalize these trends. In my test, the results were negative, which means that my idea of increasing levels of detail to trigger the bias was actually not a correct approach. The second effect that I studied is illusory correlation, in which people assume two co-occurring events are correlated. I created these bivariate symbolizations of uncorrelated datasets, and I tried to use color association in the bias-inducing version of the map to amplify a feeling of connectedness. The results were positive, but inconclusive because the differences were very narrow. So the use of color association is not enough to produce a clear difference. The next effect that I tested is the processing difficulty effect, which makes people better recall information which was hard to process. So a map with labeled cities was created, and I decided to introduce this road network in the bias-inducing version to increase its complexity and thus the cognitive effort it requires to read the information. The test showed negative results, which means that people who had the bias-inducing version of the map recalled less features from it. Now I want to discuss the ostrich effect, which makes people avoid negative, uncomfortable information. I created these two maps showing data about disease and casualties, and in the bias-inducing one, I used an inflammatory rhetoric to create more negative emotions in the user. In this case, the results were positive. The bias-inducing map triggered more negative emotions on the viewer, and they tried to avoid it as a result of that. Finally, we have the von Restorff effect that causes readers to be more likely to remember salient elements from a mostly homogeneous set. In this case, we have a set of icons, and for the bias-inducing map, I added a small rainbow to one of the icons to make it stand out more. The results were positive and close to a significance threshold, but I didn't reach it, so I consider it a weak positive. On summary, I had one strong positive, a weak positive, an inconclusive, and two negative results, and these outcomes really challenged my assumptions on how I thought the biases would operate in cartographic design. As a general conclusion, I can say that this study of distortions can contribute valuable suggestions for our field, and that many different effects can still be studied. The main result of my research is this table, which is able to compile the perceptual distortions that we have for cartography as of today. To finish, these are my references. Thank you for listening.